Okay. Looks like some people jumped. It's filling up in there now. So welcome. Thanks for jumping on. So we advertised this webinar series through Australia, though, with lots of registrations over the past week, and, we've got people from all over the world jumping on. So it's quite nice to think, we're not crazy to think some BIM fundamentals webinars is, what people might be looking for. We're doing this because BIM Store opened in Australia, more than 6 months ago now. And then, what we're seeing is there's a really broad range of BIM comprehension out there. Australia has a really slick BIM industry. There are a lot of people in there that know a lot about it. But, we deal predominantly with suppliers and, manufacturers of, product. And, some suppliers are totally on top of it, and others, may have just heard the word. So, we're hoping to help, come in, swoop in, fill some of that, bottom knowledge gap. Worth touching on, BIM Store is born out of the UK. It's run in the UK for, 12 to 13 years now, and where there's a BIM mandate. For all government projects, what that did is it just pushed BIM the whole way through the construction industry. So, home builders in the UK are using Revit. Their houses are BIM modelled. They're doing energy assessments on their homes through Revit add-ins and things like this. It's something a lot of people don't know is Queensland has a BIM mandate for government projects over 50 million. So, that'll be interesting. There'll be some there'll be some great BIM models for some of that Olympics infrastructure. But yeah, that is Australia's first BIM mandate. But it'll just be very interesting to see what happens running through, into the future. So today we're going to hear from Rob Charlton. He's going to present our first webinar of the series. Rob's the CEO of Space Group. He founded and ran BIM Show Live, and now runs a Shift conference, which revolves around sustainability and design and construction. Rob and Space Group are one of the very first practices to adopt and start using Revit in the early 2000s. Rob has fantastic knowledge. One of my favorite things that sticks in my mind, Rob tells me, when he first started designing on the drawing board, sales reps used to come in with toilet stencils. And, that's how you would specify things. That's how you would represent a product within the design. You're stenciling a toilet onto these 2D drawings. Now Rob's involved in, BIM 3, we're dealing with objects that are full of data, visually represented, great renders. People are getting a good look at these products. So Rob's really, ridden that wave all the way up to this point. And a real professional. So our format today is Rob's going to present for about 30 minutes. We'll have an opportunity for questions at the end, but you can submit questions anytime through the chat. We'll try and compile them, and we'll try and get through all of them. And so today we will be dealing with, as we've sent out, we're hoping, a semi-comprehensive capture of the fundamentals of BIM. But I will highlight as well our webinar series as a whole, this being the first one. You can sign up to the whole series. And, we will jump into some more specifics about, different parts of BIM. So on that note, I'll hand over to Rob. And we'll get a hold of him.
Okay. Yeah. Thanks, Tyrone. We're using a new system today, so hopefully you can see everything, because I can't see what you're seeing. But good morning, good evening, wherever you are watching this from. Really good to be able to present and talk to you all today about one of my favourite subjects, which is BIM. That's me. Looking old and grey, and I do. Yeah, that's probably one of the things I bring to the industry, and one of the things that I certainly bring to our organisation is a bit of lots of years of experience. So I'm, as Tyrone said, Chief Exec of Space Group, and I'll give you a little bit of an update on Space Group and what we're about, because it is relevant. Our story is relevant to this story. But I'm an architect by profession, and I was just looking today, and next year will be 30 years since I qualified. I genuinely can't believe it. That seems like an awful long time, but it genuinely has flown by. So yeah, what I want to go through today is just give an introduction to Space Group, because that does set the context, and I think Space Group's story is very much aligned to the development of the industry. So the story so far, from a BIM and digital construction perspective, a little bit about what BIM is, why BIM's important, and then maybe just look a little bit about what's next, what's coming down the line in relation to development of digital construction. So as I said, the whole idea of Space Group is relevant to this. We've been around since 1956, so we're a long-established business, and there's 4 businesses in the group. First and foremost, we were an architectural practice back in 1956, established in Newcastle upon Tyne in the north of England, still where our headquarters are, but we do work all over the world now. But Space Architects was one of the very first architectural practices, certainly in the UK, to adopt 3D modelling. We start looking at parametric software, things like ArchiCAD and Revit back in the early 2000s, 2001, 2002. And that business still continues very strong today, and very much differentiates itself by its digital workflows, and we've continued to develop those over the years. And then by about 2010, the whole organization had moved across to using Revit and 3D. We had 200 architects in the practice, all using 3D, and there wasn't many in the country at the time doing that. Then we realized a lot of our clients were really interested in what we're doing and needed some help to understand their digital strategies, BIM, employees information requirements. So we set up a consultancy, BIM Technologies, again, which is a thriving business that's based in London, and continues to grow, supporting a range of clients. We're working on things like the Google building in King's Cross. We've worked on most of the buildings in the King's Cross development in London. So that just demonstrates how there's still a need for digital support. And then around a similar time, we realized that designers and our own designers as architects needed components to put in the models, and that's where BIM Store came from. So about 2011, we launched BIM Store. And as you can see, still going strong. Really proud to have opened our office in Australia last year, and yeah, that's been an important part of building those rich models. And that's how it was for a few years. And then about 2015, 2016, a lot of our clients identified that they wanted to see some of these models, view these models. Just 2 seconds. Horrendous thing that the power was going to drop out there. Yeah, so a lot of our clients realized they wanted to see a lot of these models that they'd been investing in. So we built an online viewer, which ultimately became TwinView, a digital twin platform, and I'll touch on that towards the end of the slides. So when you add those 4 together, that gives you the progress from being a architectural practice through to construction, so from design, construction to operation. And once you start tying that all together, you can start to really see the value of digital design, construction, operation. So yeah, why is BIM? Where's it come from? Where's the value? And there's been many years of progress in the construction industry, and I think this is quite a a nice contrast. On the left-hand side, you've got Sydney Town Hall. That was designed and built about 150 years ago. And if you think about how buildings are today, on the right-hand side, that's a plant room in one of the Google buildings. And you can see the amount of services and power, air plant, heating, all sort of crushed into a single place. And if you imagine the building on the left, the town hall, the power plant on that would have been far less. There would be no cooling in there. There certainly wouldn't be any IT infrastructure. So we've seen buildings change hugely over what is actually a relatively short space of time. And then sort of today we get buildings like this designed by people like Zaha Hadid, which we couldn't do without technology, or certainly we couldn't do without technologies to look as efficient as that. So we need technology for lots of different things, which has allowed us to explore certainly different parts of architecture. And then looking into other sectors, I like this slide. It's an old advert for Range Rover, Land Rover, and on the left hand side obviously is the original Land Rover, and that I would class as quite analog. And then the right hand side, you can imagine all the computers and systems that are in the new Discovery. It's that difference between going from 50 years difference between those two vehicles. So what's the common thread in all of this? And particularly when we're thinking about construction has moved from an analog world to a digital world. And for those of us that are old enough to remember, which an incredibly there's too many people don't know what that is, but for those that don't, that's a VHS videotape. And if you don't know what a tape is, ask your parents. But we've gone from that world, which was my world probably in the 80s, to Netflix. And that's what the move that construction's done, is we've gone from VHS to Netflix. And that's the change. What I would say about the change in our industry in construction has been very, very fast. And it's been a sector that hasn't been known for change. I think we have seen a lot of change in quite a short space of time relative to progress in previous years. So yeah, going back to the first slide, and I think this is probably the fundamental of what I want to talk about today, and sort of what I will demonstrate hopefully by we've got through all these slides, is that this century, the way we design, construct and operate buildings has fundamentally changed to anything that we knew before that, and continues to change. So I don't think there's a more exciting time than today to be in the construction sector. Certainly from someone that's been in it for 30 years, it's never been as exciting, and there's so many opportunities and innovations. It's a great sector to be in. So yeah, I thought I'd start off with the story so far, where the industry's come from, where it's gone. So as I said earlier, we've come right the way back from drawing boards. As I say, I started out, even though I suppose in relative terms 30 years isn't that long as a career, but I started out on the drawing board. So you can see from where I started at the beginning of my career to where we are now, and how technology is used. In 30 years, I've seen a huge change. So this is where I started with my rotring pens, and as Tyrone said, my toilet stencils. This was pretty high tech, because that's what they call a drafting machine. That was about as high tech as they got. That's the angle element with the hand mover on the right hand side. But yeah, this is where I started. This is where it was all paper, analog, and then we moved into a world of CAD, and AutoCAD was probably the Autodesk product, which was the market leader at the time. But really all that was doing, all CAD's doing, is taking the lines that I drew with my rotring pen and producing those in a digital format on a screen. So in real terms, the progress wasn't massive. You are still doing the same thing. You probably could do a bit of copying of elements, but it still was very much two-dimensional drawings and elements. And then this is where early 2000s we really started to see a change. What came about was what's known as parametric modeling, which is where it's a 3D element that when you move one part, it updates all of it at the same time. And that was for me personally, for someone who'd come from the drawing board on the left-hand side, where if I moved a door, I had to change the elevations, the plans, all the door schedules. With parametric modeling, if I moved the door, it updated everything real time. And that for me was a eureka moment. And that was about 2000 when we saw that as an organization and could see the return on investment. And that's what we've seen over the last 20 years. We've seen that progress significantly to in certain parts of the world, very much at a level of maturity. And then the last 10 years, people have been exploring lots of different things, VR being one of them. And again, I'll touch upon at the end some of the new things that are coming through. But there's continual innovation. And in a sector that for many years, there was very little innovation. It's good to see that there is a lot of investment going in and a lot of clever people joining our sector. So yeah, so as I said, you have very much gone from drawing boards on the left-hand side. That's a digitizer. I think I just put these slides in because I like these two slides. That isn't me on the left-hand side, by the way, but that's where I did start out. And then I love the picture on the right-hand side, the guy with the AutoCAD software on his desk, and then his digitizer tablet that people probably won't have a clue at what that was. And then obviously you can see the inkjet printer behind. Quite nostalgic. I think that's why I put that in, just because it's nostalgic for me. But then this is where we've got to now. So this is the link with what a BIM model can look like, and that kind of progress from me on my drawing board to what the kind of things that are really just very much standard today. And then I just put this in. This is something, this is hot off the press from our architectural business. And this is a school. It's about 1,000 students. And our team can design that. They designed that building from a standing start from nothing to a planning application within about 4 weeks. And that's largely because there's a really strong output specification from the Department for Education, real clarity of what they want, standardized components, and we know exactly what needs to be done. By using BIM, we can produce information really quickly. It's a standardized product largely by the Department for Education. So this is kind of demonstrating where you can get to when you've got that standardization level of sophistication. I think the other big thing I would say about that is the internal skills of the team are important. That you have people that have used, this is created in Revit, have used Revit for many years. So then, yeah, just take a bit of a step back to try and explain or define BIM. There are many people over many years have got really excited about definitions and things like that. I must admit, from our point of view and from my point of view, I'm less bothered about definitions, more bothered about what it does and the practical implication of what we do. But as a definition, this is pretty simple, but it's a way of collaborating, visualizing and managing information in a 3D environment at times, and it helps with efficiency and communication. So that's what we're trying to achieve with BIM. And we'll see it change every day, and the opportunities continue to grow. So this is a nice diagram that says that BIM isn't just something that you use at the construction stage. If you've got a model, you're effectively building the model throughout the whole design process. And the way I always like to think of BIM is you're effectively building a database. So the first image that came up was how you can use your model in the software for analysis at the very early stage of the design, sun path analysis. You can then move it into the next stage where you can look at heat loss calculations, heat movement. You then move it into for creating design. The black and white image on the bottom right hand corner, that's using it for offsite fabrication. You then get right down at the detail at the bottom of how you put the building together. The next one around is showing how you can use the BIM model for logistics and movement of plant. And then we'll move on to how every individual component has lots of data, so you can use it for ordering materials, measurement, and then finally using it for operation and maintenance and the building in use. So you can see how the model completely grows, evolves, you add information to it. So you're not just using information once. And I think just an example of that, going back many years, we effectively banned SketchUp in the office. And one of the reasons for that is that SketchUp is a brilliant tool and it's really fast, but it'll only get you so far. So what we were finding was people were using SketchUp, getting to certain stages, like getting to planning and then having to start again. So the beauty of using a BIM approach is that you're constantly building on the same information and growing it over time, so you're not wasting it. So there may be, in any modeling, there may be a need for increased effort at the front end, but actually you get that back many times going forward. And then just a few examples of this was a building in that was delivered in London in 2011, and this is it's 240 Blackfriars, just off Blackfriars Bridge, and you can see that on the left hand side it was used for the logistics, very much so, and then this was a really tight plant room. So you can see how the plant was coordinated, managed, and this is sort of 10 years ago, 10, 15 years ago. And ultimately, this is the kind of buildings that are delivered now using BIM. And certainly that was a very early adopter client in London who's gone on and uses it now as just part of everyday business. So what I wanted to do now is just, this is something we call digital synergy, and it's helpful just to use as a placemaker for just understanding how we see the industry coming together, the different parts, and it helps us understand it. This was we call this digital synergy, and we started pulling this together probably 2006-07, I think, was when we first sort of came up with this idea. And the idea was, it was how we could start linking all the parts of this process together into a single place using single data. I think it's taken 15 years to even get close to this being a reality, but we had the vision for this and how you could tie that together. I think that's where you get the main value from. So it's a V diagram, and really this V diagram follows the life cycle of a building. It breaks it down into 4 parts, and the reason it's a V will come clear. So the first stage of this is define and validate. So at this stage, you use the technology to define what you want the project to be. So for example, if it was a car, you would define how many miles per gallon you want it to do, what the costs got to be, all those sorts of things. Well, this is from a building point of view, we need to have a very clear understanding of what energy use want it to be, what the cost's going to be, and do that before we start design. And as an architect, I can say this, but often designers, architects are very good at designing. They'll jump straight in and start designing it and then realize actually the client can't afford it, or it's not what they want. So define and validate is very much a desktop exercise. We then design and prototype. So this is where we use the 3D software to test things, use it for analysis. And I always say it's very cheap to make mistakes in a computer. It's a bit more expensive when you make mistakes when you're on site. So making sure you get those things tested before you start. Then we move into the manufacture and assemble stage. So we called it manufacture and assemble rather than construction, to try and take as much off site, reduce risk, improve quality. And then finally, operate and maintain is the final stage. I think one of the important things that I'm always talking about is around how we stop a stage before we start the next stage. So I'm very keen on the key milestones that we finish design before we start construction. And I think in the current world with various different procurement routes, often we can start building before we finish design. And I think that's often where a lot of the challenges come around. And also certainly from my point of view, when I was going through training to be an architect, there was very little discussion around the operation of a building, facilities management. None of that was really discussed. And I think in my day, I thought I was thinking about facilities management if I'd included a cleaner's cupboard. That was about as far as it got. But obviously now, with the impact that buildings have on carbon, that's a very important part of the cycle. And the reason it's a V diagram and we've got the dots is so that when we get to the end of manufacture and assemble, we need to go back and check, did we build it like we designed it? So all important. And then even more important is when we get to the end of construction, it's been in operation, we go back and check, is it operating as it was designed? And then it's obviously continual feedback loop to learn from what we're doing. And in another, plans of work that have come through with architectural practice, generally they're quite linear. And I think what we're keen to see here is that it's a continuous improving process. And this was our initial framework, because this is where we thought if we can start building a database in effect from the define and validate, and you build on it all the way through design, picking up all the information about manufacture and then in operation. And then, with a UK hat on and the Grenfell disaster, the whole talk about golden thread and how we can monitor, understand and retain all that data. This is effectively what this is doing. So just to talk about adoption, and this, I really like this slide about it's about the change process, going from denial, resistance, exploration and commitment. For many years it was quite good just to try and work out where the industry was and which parts of the industry. As you can imagine, for many years, certainly in the UK, there was a lot of years of denial. Certainly up until about 2011, there was denial and resistance. 2011, the UK brought in the mandate, and the world sort of, well, certainly the UK changed, and there was definite adoption from across the industry. We wouldn't have had the adoption if there hadn't been a mandate. I'm absolutely sure of that. We'd been shouting about it for 10 years and not many people were listening. And we were getting real value as an organisation out of it. And there was a small group that were passionate about it, but it didn't significantly move forward. And which was the reason why we set up BIM Show Live that Tyrone mentioned. That was in 2011 to try and spread the word. And I think now we've got countries around the world that are in, I don't think there's many in denial or resistance. I think a lot of countries are in the exploration stage, or looking at the value that BIM can bring. And a lot of countries are in the commitment area, that there is it is just what they do. And certainly in the UK, I think that's pretty much where the UK is, in that there's very few, certainly from a design practice, that companies that aren't using some sort of 3D software. In the UK, it's probably 90% Revit, but I know that it in various parts of the world that differs. Interesting, I did interview somebody recently who was working in a practice that only used CAD, and he was a young guy, and I kind of felt for him, because it's a bit like in my day using still using drawing boards when the rest of the world was moving on to computers. So yeah, talking about maturity, the common standard across the world is obviously all important, and I think one of the reasons why the UK has been able to make progress is that, one, it's a smallish country, and it's quite intense. That the cities are quite close together. This is all my theory. There's no particular intellect behind this, but because we had the mandate, the government invested in standards. We were able to quickly push the standards across the sector. And with the mandate and standards, the industry's got to a really good position of maturity. So we've got the ISO 19650 standard now, and that certainly adopted in the UK, and we're seeing increasing adoption. But we are, when I've got my whether it's BIM Technologies or Space Architects hat on, BIM store, different countries approach things very differently. So in America, we've got a presence in America, and obviously you've got lots of different states all doing different things, all with different kinds of maturity. So that you can see the challenges. That's why, because the UK is quite small and intense together, I think that's how the UK has been able to adopt 19650. But it is being adopted around the world, and there's certainly people looking at it. That just gives you a bit more detail around 19650 and the 6 parts, which are very valuable. But yeah, you can see around the world there certainly is participating members of the ISO standard to a greater and lesser extent of adoption. Some countries have a BIM mandate, some have plans, some don't, but you can see there across the world that certainly the story is spreading, and that wouldn't happen unless people were seeing some sort of value from BIM one way or another. So then, just moving on to why BIM. Why do we do? Why are we thinking about this? Why are we making all this investment? What's the change? What's the value? And very simply, from our point of view, so when we started out, we delivered our first. Get my dates right here. We delivered our first building in 2007, I think, was when we delivered our first building, and we did a test at the time. We couldn't get enough resource. There wasn't enough people. There was a big surge in public sector work, so we couldn't get enough people. So we decided to invest in technology. And at the time, we had an office in Leeds, an office in Newcastle that were doing very similar schools. And the one in Newcastle had 2 people on it using Revit, and the one that was out the Leeds office had 6 people, and potentially up to 8 at one time. So from a return on investment, yes, it meant a lot of training. The hardware and software was expensive, but it helped us because we couldn't get the resource. But also, when you started adding up all of the costs and the time, you could see the real value. So from a practical point of view, the efficiency, the reduction in time is a big part of it. But coordination, a lot of the challenges with construction has been, and certainly again, when going back to in the very early days when I was creating 2D drawings, you wouldn't know if something was coordinated until it started to get built, because you were looking at 2D plans, and it wasn't until it all came together. So one of the great things about BIM is that you're bringing all of your pipes, wires, structure together, and you can coordinate it off-site rather than a fitter coming on alongside and seeing that the pipe work is clashing into the steel work. So obviously coordination is important, and these are just some of the examples of typical examples of the kind of things that when you're doing clash detection, the amount of things that you find that are generally resolved on site and you don't know about, but we find hundreds and hundreds of clashes in models, and far cheaper. So talking about return on investment and why BIM, the amount of money and energy that saves is huge. Waste, this sort of ties in with the previous point of coordination, but by getting things right first time, we can reduce huge amounts of waste, managing the size of materials, getting boards the right size, getting things right first time. So I think that one of the big things there, and we've seen with a lot of live projects, that it's made the whole process more efficient. It's helped with offsite manufacturing because you can get things to be designed offsite for factories and things like that. And then sometimes overlooked, but communication, something we take for granted maybe now, but how we can walk around buildings so easily now. We can understand them before we get anywhere near the building site. We can test things. Large screens like this are pretty typical on a lot of building sites now. There's all sorts of different kinds of software and screens and projectors. which make a huge difference, helping in planning. So it's really good from a safety point of view. So much value. And then, yeah, the whole time element, reducing time, planning offsite. This is a great example of where Trimble are overlaying virtual pipes over a existing building. You see there they've got VR goggles on that are looking at how things are all fitting in the same place. So there's lots of different ways that a 3D model can help reduce time. And then just moving on to that, the why BIM from a production point of view and how we produce information, but how building owners use buildings, need to consider buildings, has changed hugely. And I put this as an example of a WeWork type office, just because, if I think back to those 30 years ago when I started out, thinking of an office space looking like this would be unthinkable. It was very traditional desks, everyone in the office at the same time, very little flexibility. Now business has changed enormously. So how building owners look after the buildings, what they have to do, they have to be a lot more flexible. And I think digital construction and BIM can certainly assist with that. The whole side of, and again, I'm referring to the UK here in particular, but the rest of the world has had similar disasters. But Grenfell was a dreadful thing that happened in the UK. 72 people lost their lives, and a lot of that was around, not all of it, but the construction sector played a significant part in the responsibility for what happened there. And now, probably a bit late, it's certainly shutting the gate after the horse has bolted, that there's a lot more stringent compliance requirement, certainly in the UK for high-rise buildings, but other buildings as well. So there's new building acts in place. So building owners want to know that the information they've got's accurate. They've got a auditable trace of who did what when. So the digital environment can help with that, can create a digital logbook of what's happened. You can get a lot more granularity of data in there. So I think the benefit of BIM for compliance is significant. I've touched upon the sustainability side of things, and this is very much over the last couple of years, front and center. We see it all the time. All of our clients have it very much in their own business plans and their own strategies. So being able to help them understand the buildings more, having 3D models to demonstrate volumes, the amount of materials, energy systems. It's far easier to do that with a sophisticated data-rich model. And we're going to see that more and more as the years go on. And then smart buildings is a huge area of advancement. People are expecting a lot more from the buildings. We've got the idea of putting a car in here, what cars do. There's no reason why we can't have our buildings as smart as cars are. So control systems, people wanting more connection with their buildings, more control, turning lights on and off, temperature with mobile devices, and all of this technology is accessible now. So expectations are certainly much higher than they've ever been. So yeah, I said I'd touch upon what's next. So this is this sort of, that's probably about a 10-15 year story with ranging levels of maturity around the world. Mine's a 30-year story going back to rotring pens, and as I say, it was progress was slow, but certainly over the last 5-10 years we've seen a significant increase, and I think the next 5 to 10 years will just take it to another level. The momentum's moving, the strong foundations, and I think we'll see it doubling year on year for progress. So yeah, what is next? Where's the big area? And certainly where we see it, looking at the digital synergy side of things, very much around operate and maintain, and using this digital information that's produced through design and construction, and understanding that more. Our buildings are producing huge amounts of data that's just not being used. And then I've obviously, as you'd expect with any current presentation, is having artificial intelligence in there. And the whole point of our digital synergy approach was that you'd ultimately be putting all of this data through design and operation into a metaphorical bucket, which is we're grabbing that through this process, and then overlaying artificial intelligence to predict, optimize, see patterns, and with a few, our TwinView platform, for example, that we're taking information in from operation, and we've started some early work with artificial intelligence using things like ChatGPT, and the outcomes are amazing. I think because of platforms such as Chat, the whole artificial intelligence potential has grown hugely and very quickly, probably 5 years before anybody thought it would happen. So I think the potential of AI in our sector across all of those 4 stages I've got there is enormous if we grab data. And the reason you can see there that as we learn from this AI, it can go back into that triangular approach and continually improve what we're doing in the sector. And then, as I said, yeah, this is it's not supposed to be a sales pitch for TwinView, but digital twins are very much of the moment. There's a lot of talk about digital twins. We spent the last probably 7-8 years developing TwinView, and it's got to be a digital twin that adds value. Where we're seeing digital twins is taking the information that's been produced, these fabulous models that have been created in through the design and construction, and then using them into operation, because that's when they really can start to add operational value. So having an easy way of putting them on, making them accessible, and then adding all of the data. So we see digital twins over the next few years continue to grow. So here's a good example of all of the effort and energy that designers put into creating a valve and all the data. This is demonstrating where that has value. So in a platform like TwinView, you can see sort of bottom right, there's a little blue valve there. All the data is on the right hand panel there about that particular valve. So when it's changed, you can maintain the information, and that will continue to grow. And then, yeah, same sort of idea here, how all of your information is in a browser, accessible. And this is not sort of state of the art. This is kind of what's happening now. This is out the box. It's been around for a few years. So it's, this is maximizing the value of the investment in BIM through design and construction. And then obviously you can connect that up to your building management systems and get all of your operational data, which, going back to that sustainability side of things, is important to a lot of building users, particularly when energy costs are increasing and people want to get their carbon usage down. And then the other thing is how you link people into your buildings. And this is a tenant experience app. So this links into the building. So this is how you're connecting the use of the building on a day-to-day basis with maybe with the systems. And then you can start to see how, by taking that usage information, how many people came into the building, how the meeting rooms were used, with sort of temperatures, weather, you can then start to apply artificial intelligence to identify patterns, what you need to do to optimize it, make the building more efficient, reduce costs. That's certainly coming. And another big area that's been evolving over the last probably 5 years is generative design. And probably over the last 18 months, there's some really interesting products coming out that have a commercial position. We've been looking at a few of them, but really good for quick optimization, feasibility studies, and there's more and more products using this kind of technology. And certainly for early stage, we've used it and found there's good value in it. So I think over the next few years, we'll see a lot of generative design coming through. And then our friends at Apple, spatial computing, it's a bit of a question mark. Who knows what this could bring, but the potential you can sort of see for the industry is really interesting. So taking these models, using things like what Apple are developing, but you can see the investment, millions, if not billions, going into AR and VR technologies. And then, yeah, as I say, finally, the artificial intelligence element of our industry is probably going to be have the biggest impact over the next 3 to 5 years. Already seeing some really amazing results from a lot of information. A lot of the things that we've been doing for many years, we're going to be able to start and look at learning from what's happened over the last 10 or so years whilst we've been collecting data. So I think that's me. Covered a lot of ground there. Thank you for continuing to listen. If there's any questions, I'm more than happy to talk us through.
No worries. Thank you so much, Rob. Yeah, we've got a heap of questions here. I'll try and get through some of them. So a good one is starting here. The practice we use uses ArchiCAD. Is that also BIM if it's 3D?
Yeah, absolutely. You know, in the UK, Revit has become the de facto, but there's equally good, if not better. I mean, I remember when we decided to run with Revit at the time, I think there was better products out there. ArchiCAD was probably more mature at the time, but we made the decision to go with Revit because we're already an AutoCAD user, and we did think that AutoCAD had the deepest pockets to develop it. But there's some great, ArchiCAD's a great product. Vectorworks, lots of, you know, it's all the same principle. Is there any other questions?
Yeah. Okay. Yeah, we've got a heap here. So someone's asked, we are an insulated panel provider. Will BIM or Revit help architects determine the correct use of our products for thermal values?
Yeah, absolutely. I mean, you've certainly being a insulation provider, you've sort of hit on one of my major passions around the value of BIM and data. Making sure that information is accurate. Obviously, what happened at Grenfell is absolutely critical. So insulated panels, getting that data accurate, getting it validated by the manufacturer, that information is then put into environmental modeling software, for example. So Revit can calculate U values of walls. So that's why you have to have, to do that, you have to have the accurate manufacturer data in there to allow you to get that accurate result out of that calculation. So for many years, we've been passionate about, and obviously with having BIM store, and the reason we had BIM store is we wanted accurate manufacturer information, not generic information. We need, if you're going to generate a true model in every sense of a building, you need the true performance of products. In particular, insulation is from a energy point of view is important, but also fire safety. Obviously, certainly for those of us in the UK, fire safety is absolutely essential now with the Building Safety Act and what happened at Grenfell. So accurate manufacturer information is essential.
And obviously a big effect on Australia as well with our combustible cladding. Changes in thousands of buildings getting recladded. So, okay, so someone's who is responsible for managing the model once projects have been awarded to builders?
That's not that can vary. So it's a good, generally on the projects that we've been involved with through a design and build contract, generally what happens is that up to sort of mid-design, obviously stage 4 in the RIBA planner works in the UK, that it might be developed with the client and the architect. Then the architect would be novated and the design team be novated to the contractor, and generally the contractor under a design and build contract takes control of the model. They then start adding in, so there may be, and I'll simplify it, so there may be at coming towards the end of design, there might be 3 models: architect, engineering, and structure. And then as it gets into detailed design, you then start adding in your subcontract models. So you might have three initial models, but then you start adding in subcontract models. You can have hundreds of ultimate models when they're all coordinated together in a single model. And then what would happen is the main contractor would take responsibility for that model. They would then make sure that it is an as-built model. So there's as designed and there's as-built. And then that would be handed over to the client at the end. As well as handing over the building, you're going to hand over a 3D digital representation of that building for the client, who then could go and use it in something like TwinView for digital twin. So you got that ongoing. That's what we see. People made a huge investment in these models. You want to get the best value out of them into operation as well.
Yeah. Okay. There are some more questions around facilities management here, but I'll condense them in that people are asking, so how does BIM support facility management? And you did touch on TwinView, but I get what things are people working out with AI with their digital twins?
I think it's, there's a lot of people, again, having been in the digital twin world now for the last few years, there's a lot of people making lots of noise around AI. The truth is there's not much out there. One of the biggest challenges with our industry is that there's not a lot of data. We've had a PhD running now for nearly 3 years around energy prediction in buildings. And when the data scientist started the project, the first thing she asked was, so where's the data sets? Well, because if you're a data scientist, you need data. And we go, well, actually, there's not a lot of great deal of data. And you actually go and try and find much operational data on buildings. There isn't a great deal out there. So I think there's some people doing small parts with AI, but I think over the next 2 or 3 years, you will see some amazing things come out because the progress is so fast. Certainly with the work we are doing, and we'll be able to go public with probably in about a year's time, is you're going to have a massive difference. And I do think facilities management in its broadest sense is where there's real value for us all to bring, because that's where one of our greatest responsibilities as designers and constructors in our industry and clients is to reduce the amount of carbon, whether that be in construction, in operation. That's got to be one of our priorities.
Yeah. Okay, fantastic. Okay, I've chosen 2 more questions, so I love both of these. So how close is BIM getting to VR, in terms of a full setup and where you can walk through your building pre-construction?
There's a lot of people doing that now. It's if you've built a quality model, there's that technology's been out for a long time, and we've in Space Architects business, we've got a full graphics VR team, so you can put a headset on and walk through your building. The truth is, though, there's not many people do. It's people haven't. We've had it for probably 8 years, I think. You create a model, you put a headset on, quite easily you can walk around that building, and you really do get an amazing sense of space. You really do feel like you're in that space. And what's really good is if you're not used to looking at plans and visualizing plans and what they're like, great for that. So for example, if you're designing a school, you could put a teacher in that classroom so you get a feel for it. The truth is, though, people just don't. I think people are very self-conscious of putting those headsets on. So until the hardware improves, I don't think it'll be used a huge amount. That's the truth of it. That's what we found. The theory of it's great, but in practical levels, we don't see it used a great deal. People still the other thing that's great that comes out of BIM is that we use digital printers, and it's so quick to take your BIM model. There's some great software, just takes it, put it into the software, and it literally will print your building in it's not minutes in a few hours, but it's as easy as that. The workflow is, so the buildings you've seen there, you could quite easily just put into a digital printer and it'll print you a version out within a few hours. That's probably more that I've seen that used a lot more for rapid prototyping than I have people using VR and AR.
Yeah. Okay, fantastic. Okay, last question. I'm sorry to the other people that have asked questions. There's no way we'll get through all of these, but probably my favorite question is, how does BIM capture carbon content in buildings, or Revit for that matter?
How does BIM capture carbon? Well, yeah, I'm just understanding the question. Yeah, so again, it's a good question and an important one. I presume it's around embodied carbon, and it's actually, I don't know if you set this one up on purpose, Tyrone, but I'm sure you haven't. But one of the later in the year, we're going to we've got a new release of BIM Store that comes out, and it's very much around embodied carbon and environmental declaration certificates, because we're finding that's really important to designers now. So if you're going to go and pick a one block against another, you're going to want to try and pick the one with low embodied carbon. So the beauty of having a model now, there's attributes in every element of material that's in the model. So there's software like one click LCA that effectively takes the model, breaks it down into its individual elements, and then adds the embodied carbon element. So you can work out what the embodied carbon amounts were. And again, we've got another research project running at the moment around this, and it's not straightforward, and there's quite a bit of work in it. But I see a lot more of that coming. People investing in carbon calculations, and again, I suppose I'm bound to say this with being involved with BIM stores, but that accurate embodied carbon data in your product. So if you've got a product and it's a really good performing product environmentally, it's going to get picked in the new elements of BIM Store coming out later in the year, allow you to do that comparison between the different kinds of products, whether it's a really low embodied carbon, high embodied carbon. It's just another element. Once you started building that database that I was talking about, once you've got that data, you build on it, it gets richer and richer. And a lot of these things that we're doing now improve the industry we couldn't do if we hadn't started building digital databases in the early days.
Yep. Beautiful. Okay, so we'll wrap up there. Thank you so much for everyone that jumped on, all the good questions. Thank you, Rob, for those. I will put on again. I'll just share on the screen. That is, we'll send out some more information. That is the ongoing webinar series. This one has been recorded. So if you found it useful, it'll be on our resources page. You can send it to your colleagues. Any feedback, we'd be happy to hear it. Anything else you want to know, we'll try and answer some of the other questions that have come through the chat directly. And yeah, thank you for jumping on, and have a great day.
Thanks, Tyrone, and thanks everyone for listening. Have a good day. Bye.
Bye.